All right, just a heads up as we work through this video, then it's going to give you some pauses for you to respond to the questions before we go over them together. So we're talking about the value of a computer. Here is a graph representing an exponential function. Remember, exponential functions have this curvature to them. It's the function f. The function f gives the value of a computer in dollars as a function of time, which they use the letter x for, measured in years since the time of purchase. So based upon this graph, and you can take a second and pause me at any point that you need to, what was the purchase price of the computer? So the purchase price of the computer is going to be when that x value is 0. And we can see that at that time, it was $400. Let's look at question B. So again, the purchase price is that initial value or that starting amount. For question B, what is the value of f when x is 1? So if we look at when x is 1, we can go up on our graph, up to 1, and then we can go over and see when our x value is 1. Remember, in our ordered pairs, it always goes x and then y. When our x value is 1, our y value is going to be 200. So the value of f, or the value of that computer in 1 year, is $200. And that's what the meaning of f of 1 is. So I kind of answered that one for you. So that means our function, when it is 1 year in, gives us that output of 200. So our computer at 1 year is $200. All right, I won't give you the answer to D. So how is the value of the computer changing each year? So I noticed that the value went from 400 to 200. Then it went to 100 in year 2. So what is happening from 400 to 200 to 100? Think about if you can revise your answer any, or were you correct the first time? So the value is changing by 1/2. Half of 400 is 200. Half of 200 is 100. We're dividing by 2, which is the same as multiplying by 1/2. So let's make an equation to define this. Hopefully you remember on Tuesday, the video that you watched about exponential growth and decay. Hopefully it feels really fresh in your mind. But our function f, when our input, our x value, equals our initial value in this case we found was that starting amount, so that's 400 times our growth or decay rate. In this case, it's decay because that's less than 1, and also this is going downwards. So we have a decay rate of 1/2, and we put it to the power of our time, our input, or in this case, we're using the letter x. So now let's figure out for question F, whether the value of f will reach 0 after 10 years. Think about that, see if you can calculate it. So in order to solve this one, then our input's going to be 10. We know using order of operations, we have to do the exponent first, so 1/2 to the power of 10, and then we multiply that by that initial value. And when we do that, it's going to be about 40 cents. So it's not making it to $0 yet. It is not worth much money at all. It's only worth 40 cents, but it is worth something. So that is kind of an interesting thing about exponential decay like that, is it doesn't ever really exactly reach $0. It may be a fraction of a cent over time, but it's still going to be worth something.